Hello, and welcome back to BURECS Channel 9 News. I'm Owen Woodcock.
And I am Jeffrey Atwood, and we are your hosts for this evening.
Tonight, we bring you a shocking new report on the state of the West Antarctic ice sheet.
The ice sheet is mainly at sea level, and so it is quite sensitive to rising global temperatures.
That's right, Jeff. And there is a possibility that it could melt in the future, causing sea levels to rise between 9 and 20 feet.
Wow, Owen, that sounds pretty extreme. Should I be worried about stocking up on supplies for the coming floods?
Thankfully, we're not there quite yet. Remember, this is a matter of climate and not weather.
Of course, you're right. Climate is the weather patterns over a long period of time, whereas weather is the short-term patterns.
That's exactly right. For us, this means that sea levels will rise up to 6 meters due to Antarctic ice melt over the next 50 to 100 years.
Now to our reporter in the field. Julia?
Thanks, Jeffrey and Owen. I'm here at the Esplanade across the river from Harvard. Right now, the water level in this area looks pretty normal. But as rising global temperatures continue to affect the West Antarctic ice sheet, people around here might start to get a little bit wet. According to the city's Climate Ready Boston report, which was released last year, by 2070, sea levels in Boston may be up to 3 feet higher than they were in 2000. And these are just the predictions from one study. Some other studies predict even more. It all depends on how much of the ice sheet in Antarctica melts, plus how many other factors might contribute. Moving forward, the danger of flooding in Boston is likely to get even worse. More than half of Boston is already built on tidal land, and a lot of areas, like the Esplanade where we are now, already have flooding issues. By 2070, severe floods that affect up to 5% of the city may happen every month. Back to you guys.
Thank you, Julia. And of course, this is not the first time that the ice sheet has been in danger of melting.
That's right, it completely melted during the Pliocene epoch, which lasted from 5 to 2.5 million years ago. But how do we know this, Jeffrey?
Well, Owen, there are many things that show us that the West Antarctic ice sheet melted during the Pliocene. The lower dissolved oxygen levels and fewer microscopic marine animals in the ocean during that time period indicate warmer conditions, both in the ocean and in the atmosphere. Because of the high sensitivity of the ice sheet to warmer ocean temperatures, increases in temperature as high as 3 degrees Celsius was able to cause the total collapse of the West Antarctic ice sheet over a few million years.
Modern global conditions are quite similar to the Pliocene, which leads scientists to believe that the ice sheet could melt again.
But how do we know that the conditions are comparable? For that, we go to our very own local expert, Grady Gillett. Grady?
Thanks, Jeffrey. We have lots of different ways of learning about the global climate during the Pliocene. We use these things called proxies to indirectly study the ancient past. We can analyze Antarctic ice cores, as well as marine and terrestrial sediments and fossils, which give us a rough idea of what the world was like back then.
And what proxies are you looking at, Grady?
My colleagues and I have been working in the McMurdo Dry Valley in Antarctica, where we collect ice cores like this. There's some silt trapped in one specific ice core, and this silt only comes from standing bodies of water. So we know that this area was once covered in water and not ice. So obviously it was above
But can you
freezing.
get any more specific than that?
A great point, Jeffrey. By studying the boron isotopes in the shells of tiny marine animals, my colleagues and I can estimate the dissolved CO2 levels in the water, and from that, the CO2 in the air at that time. Those CO2 levels help us estimate what the average temperature was back then, and we believe it was about 3 degrees Celsius warmer than it was today.
So what are your conclusions, Grady?
Well, the CO2 levels of the Pliocene and modern day are nearly identical. They're both around 400 parts per million, so I think we can definitely expect to see conditions that mimic what was happening during the Pliocene.
Thank you, Grady. Owen, that seems pretty convincing to me, but have we observed any melting on that ice sheet recently?
Unfortunately, we have. Since 2002, the ice sheet has been losing 125 gigatons of ice and snow every year. This is truly incredible, Jeffrey, because just 1 gigaton is 2,500 Empire State Buildings.
That sounds absolutely ridiculous. I know CO2 levels are high, but that seems like a very rapid decrease. How would you explain this?
There are many components involved, but some of the most important are a set of positive feedback systems that are causing ice sheet collapse.
For those of you who do not know, positive feedback systems are basically domino effects. They amplify their own effect by continuing the process that initially started the cycle. They tend to cause instability and drastic changes in the environment.
Some of these systems include decreasing reflectivity and ice sheet height, increased volcanic activity, and melting permafrost.
Thank you for that, Owen. Julia, is the city doing anything to prepare for this?
Yes, actually, the Climate Ready Boston initiative, which collected a lot of the research that I mentioned earlier, is also helping design solutions for making buildings safer as sea levels rise. New building codes will encourage property owners to elevate their first floors and move important items, archives, and equipment to higher floors due to rising sea levels. There's also been some preliminary talks about building a seawall out in the harbor, but that's a more expensive and long-term project. Back to you, Owen.
Thanks, that makes me feel better. Now, for our next story, can scientists control the weather? With a guest appearance from Donovan.